Chapter 26, Example 4. Investigate the association between average monthly temperature, degrees Fahrenheit, and electrical usage, kilowatt hours, for a home. Is there evidence of an association between average monthly temperature and electrical usage? Fortunately, we have all of our statistics that we need along with the graphs that we need to look at: residual plot, histograms, scatter plot. So we'll start with our null hypothesis, which is that beta 1 equals 0. In words, this means there is no association between average monthly temperature and electrical usage. The alternative hypothesis is that beta 1, again our slope, does not equal 0. So we're saying there is an association between average monthly temperature and electrical usage. So we need to check the conditions. We'll look at the scatter plot first. Scatter plot is in the top left image there. It looks like it's linear with no outliers. The scatter plot of average monthly temperature against electrical usage is negative and linear. With no obvious outliers. Now we have a residual plot there. It looks pretty spread out. I don't really see a pattern. With more points, it'd be more spread out, but it's pretty decent. The residual plot shows no obvious patterns or trends and has fairly consistent spread. Okay, now let's look at the histogram of the residuals, top right. It's real data, so it's never going to be perfect, but it looks pretty good. Unimodal symmetric, no outliers shown there. Furthermore, the histogram of the residuals is unimodal and roughly symmetric with no outliers. The conditions are met. I will use a student's T-model with 10 degrees of freedom for a regression slope t-test. All of our statistics are provided for us there. We'll go ahead and state those, put them down here at the bottom, and then we will analyze that data. So T is negative 10.2. Our p-value is less than or equal to 0.0001. And we have a model of kilowatt hours hat equals 3,898.20 minus 50.9027 times the average temp. We get all that data again from the computer printout there. The p-value is less than 0.0001, which is very low. And I will reject the null hypothesis. There is evidence of an association between average temperature and electrical usage. On average, electrical usage decreases as average temperature increases. Explain the association using a 95% confidence interval. Since we just have the statistics here, it's a computer printout, we're going to have to find this by hand. Degrees of freedom are 10. T star with 10 degrees of freedom will equal 2.22814. We can find that from a table, or more accurately doing an inverse T in the calculator. The standard error of the slope equals 4.980. So our margin of error will be 2.22814 times 4.980, T star times the standard error of the slope, which equals 11.0961. Our 95% confidence interval will be negative 50.9027, our slope, plus or minus the margin of error, 11.0961, which gives us an interval of negative 61.9988 to negative 39.8066. Now we'll state our interval in context. I am 95% confident that electric usage decreases on average (39.8 to 62.0 kilowatt hours for every 1 degree increase in average temperature.